Good morning, class. You guys had some homework? The homework was on page 617. 16. Okay. Exercise 6 on page 16. Was there any issues? Number 3, number 4. Anything else? 3, 4, 5. Okay, exercise 6 on page 16, number 3. The question says determine the sum of the series. You've got 54, 18, 6, and it carries on all the way to 2 over 80, 81. So to calculate the sum of the series, we know we're going to use the formula Sn is equal to A into Rn minus 1 over R minus 1. So at this point we got our A value. We got A to be 54. Not so? We have R to be term 2 over term 1, which is 18 over 54, or 6 over 18, which is 1 over 3. Correct? So we know that this is the nth term of the sequence, or the series in this case. So to use the formula, the sum of formula, I still need to know what n is. Not so? So to calculate n, I then work out Tn, which is Arn minus 1, and set Tn equal to 2 over 81. My A value is 54 into R, which is the third, n minus 1. What's the next step we need to do here? Divide by 54 both sides. That cancels. So that will simply be 2 over 81 must be divided by 54. That gives you 1 over 2,187. 1 over 2,187 equals 1 over 3 raised to the n minus 1. So what I do is I need to know what 2,187 can be written as 3 to which exponent? 3 to exponent 7. So in other words, this here would be 1 over 3 raised to the exponent 7 equals 1 over 3 raised to the exponent n minus 1. Therefore, n minus 1 is equal to 7, which makes n equal to. But I ever answered the question? No. The question was for the sum of the series. So we're going to use Sn is equal to S8 would now be equal to 54 into a third raised to the 8 minus 1 over a third minus 1. That will simply be 54, 1 over 3 9 minus 1 okay, minus 1 over a third minus 1 gives us 6,560 over 80. Okay, so who asked for this question? Question 3? Who asked question 3? Where did you go wrong?
So I on top is 2 over 81 because
2 over 81, yes?
I think I put it over 1 with 3 minus 1.
So you said 2 over 81 is equal to 54 into, just write the sum down.
And I said that over a third minus 1.
A third to the minus 1. That would have been correct till an extent. So this here would have actually cancelled that only. Then you left 2 over 81 divided by, so what did you get once you divided 2 over 81 by a third?
I will stop this.
Negative 1. You should have gotten that there. Let me just see if I can. It's 2 over 243 equals 54 into a third raised to the n. Then your next step would have been is to divide by 54 as well. So if I divided that by 54, that answer by 54, then I would have gotten 1 over 6561. Then I would expect that to be 2 to the 8. 6561. Yeah, 3 to the 8. Then you would have gotten the same answer. Okay. But the logical thing to do is to rather get rid of the 54. And then I'm left with the base. And remember, when the bases are the same, exponents are equal. Okay, so let's then do the next one. And the next one was question. That was the issue, was question 4. No? Somebody asked for question 4? Correct? One over 625. 1 over 625. Okay, miss. Okay, so the question says determine the sum of the series. Okay, again same story. That's going to be the nth, we let that be the nth term. Okay, so your A value is going to be 3125. Your R value is going to be term 2 over term 1, or term 4 over term 3, which is 1 over 5. Correct? So my general term is Tn is equal to ARn minus 1. Your nth term is 1 over 625 equals A, which is 3125, into R, which is 1 over 5, n minus 1. So what's the first thing we need to do? Divide by 3125, both sides. Okay. It now gives us 1 over 625 must be divided by 3125. Okay, it's going to be 1 over 1,953,000 125 equals 1 over 5 raised to the n minus 1. Okay? I'm sure that number there can be written as 1 over 5 raised to some exponent equals 1 over 5 raised to the n minus 1. To what exponent can that be written? We say 1,953,125 equals shift to factorize 5 to the 9. Okay, so that will be 9. So therefore, n minus 1 is equal to 9. So n is equal to 10. Now I can use that formula which says Sn is equal to a r to the n minus 1 over r minus 1. So what's your a value? 3125 into r, which is a fifth, raised to the 10 minus 1 over fifth minus 1. So it's going to be 3125 open brackets 1 over 5 raised to the exponent 10 minus 1 over 1 over 5 minus 1. Is that correct? 3906 comma 25. Who asked this question? Where did you go wrong?
I divided 1 over 5 into 9 by 1 over 5.
So you divided at which point? The year. Year.
Yeah.
Okay, I made a mistake here.
Yeah.
So you got this answer here. Then what you did, you divided by 1 over 5.
To the minus 1.
Okay, so you should have gotten, so when you divide it by 1 over 5 raised to the 1, then on the left hand side you should have gotten 1 over 5 raised to the n. What did you get on the other side?
I got 39,065. When I divided that 1 over 5 raised to the minus 1.
So you see 1 over 1,953,125. So you divided that by 1 over 5 raised to the negative 1. Is that what you said? So is that what you got as an answer? That's your mistake. Okay. If you're going to divide that, is that what you got?
But I didn't get the 1.
What did you get?
I just got 39,065.
Without the 1 over.
Yeah.
So you, in other words, you said 1 over 5 divided by that number. This is what you got. Oops. You got 1 over 5, and then you divided that by. You got that? Oh, this is I put the extra one.
Yeah.
That 30. But remember, this is 5 to the minus 1 first. 1 over 5 to the negative 1, that's number 1. And since we're dividing both sides by 1 over 5 raised to the 1, that 1 over 1,953,125 had to be written first as well. So you made more than one mistake here. Okay. Again, it's going to be safer just to play it as easier. Make the bases the same for the exponents to be. Okay. So we don't want the sum to cost you marks in the exam, you understand? So the sum is fairly simple. There's a lot of calculations to be made. Okay. And you see how one mistake in the sum can throw you out a bit. You will still get part marks if you can carry on with the sum, but you will lose 1 or 2 marks. Okay, the last question, question 5. Determine the 5th term of the series if you are given the Sn formula. So remember, if you are given Sn, what do we know? How do you work out Tn? We spoke about this already. We said to work out Tn, it's going to be Sn minus Sn minus 1. You guys remember that? So you want to work out T5, term 5. It will be S5 minus S4. Not so. S5 minus S4. Are you all okay with that? If they will ask you to work out T15, how would you have worked it out then? S15 minus S14. They want you to work out T2. S2 minus S1. They want you to work out term 1. Just S1. Not so. So T5, the 5th term, is going to be S5 minus S4. So wherever I see here N, I put a 5. So there goes a 5, and there goes a 5. In the next one for S4, there will go a 4, and there will go a 4. Okay, you guys okay with that? Alright, so we say S5 is going to be 243 over 2 into 1 minus 1 over 3 raised to the exponent 5, close bracket. So that is S5 minus S4. Again, wherever you see an N, we put the 4. So it's 243 over 2 into 1 minus 1 over 3 raised to exponent 4. What's the difference between the square brackets and the curved brackets? Huh? Nothing, it's the same. Not so? Just to indicate one is the outer bracket and the other is the inner bracket. That is why in this sum they got the same bracket, it doesn't matter. Okay. Now I'm going to give you a different answer. So let's put that in the calculator. It's 243 over 2 into 1 minus, open brackets, 1 over 3 raised to exponent 5 minus 243 over 2 times 1 minus 1 over 3. I don't think you actually need this bracket here. You want to enter in the calculator. But okay. So answer 1. The answer is 1. Okay. Who asked this question? Yes, where did you go wrong, Michael? You forgot about the formula, right? Write down the formula again, highlight it. Alright. If this sum had come in, it would have been 3 marks, man. Okay. 3 marks set. We don't want to just throw away like it. Easy 3 marks. Alright. So yesterday we spoke about the sum to infinity, and I asked you to read through the bottom of page 16, and then we spoke about a series that converges, or something that converges. Converge means to say 10 to 0, as n tends to infinity. Okay. And in yesterday's lesson we ended off with this here. Not so? Okay, so I'm going to start again with that there. So work on my handwriting, no? No? Okay, good. Alright, so we said we're going to look at the formula. Sn equals A Rn minus 1 over R minus 1. Okay. Then the condition will be met, as I said, if R, the series will converge if R is greater than negative 1 but less than 2. Now I said if R is also, you're not going to consider if R is equal to 0. Okay. So I gave you an opportunity to choose a value for R. And what value did you choose yesterday? A half. Not so. So we said, okay, let R be equal to a half, which now conforms to the condition given there. It has to be between minus 1 and 1. Okay? So I'm extracting this part of the sum. Alright? So let n equal 1. Or let's say if, one just let everything out. If n equals 1, then you will have half raised to the 1, which is 0.5. Not so. It was half. Let's choose another one. If n is equal to 2, well, let's go in 5, increments of 5. Then you got 2 to the 5. Work that out. Zero comma. So that will be 1 over 2 raised to the exponent 5. 0 comma 0 3125. 0 comma 0 3125. What if n is 10? It will be 2 to the 10. To get it in normal decimal, we press shift. You'll see on top of this button, this engineering button here. There's an arrow to the back. So you press shift, that's about engineering, shift engineering. So 10 to the 0 is 1, anything to the power 0 is 1. So that number is actually 0, 0, 0, 0. 0, 0, 0, 0. 3 zeros, 9765. And of course the number carries on. What will happen if n is equal to 15? So let's say something like this. So as you can see, there was 3 zeros before the number actually started. So if you're going to go, you just go 15, 10 to the 15. Shift engineering. So that's 0 comma, there's 4 zeros now, no? So half to the 15. So 0 comma 0 0 0 0. 3 0 7 and the number carries on. Let's do one more. So let's make n 25. If you're going to go with 20 first, without writing it down, we just show you something. That's 0, 0, 0, 0, 0, 0, 0, 9, 5, 3. So you go to the 25. That's going to be 2, 4, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7, 2, 9. And of course the number carries on. what you notice as this exponent is getting bigger, as this is, infinity is a very, very large number. Not so? So what do you notice as this number is becoming bigger? What if it goes to 15? Then there's 16, not 16 zeros, but a lot of zeros before that 8 actually starts. What if you go to the exponent 100? There's even more zeros before the number starts. So that's going to be 0, 0, 0, 0, 0, quite a bit of zeros before you get that 7, 8, 8, and so on. So what do we notice if n approaches a very large number, or if n approaches infinity? Then what can we conclude? What do you notice? The numbers, say it, the numbers getting smaller, yes. So as n becomes even larger, what do you then notice? Then r to the infinity will approach 0. Not so? So as that number, as n approaches infinity, then r to the n has to approach 0. Okay. So we can say as n approaches infinity, then r to the n approaches. That's a rule given that r is greater than -1 but less than r is greater than -1 but less than 1. Does it make sense? Let's choose any other value between a -1 and 1. Let's go with the third. Or fifth. Let's go with the fifth. We started off with the exponent 1. So that was 0, 2. Let's go to the exponent 10. There you are ready. I have 6 zeros before the 1. Can you see? Let's go to the 12. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So 9. So 8 zeros before the 1. Before the 4. So what do you notice? As that exponent approaches infinity, or as that exponent increases, that number will actually approach infinity. And that's why we say that this r to the n will, what did we say? Converge. What does converge mean? It tends to a number. It tends to 0 in this case. Does it make sense, people? And what condition has to be met for the sum to converge? R has to be greater than -1 but less than 1. So if we're looking at r is greater than -1 but less than 1, what does that already tell us? That this can only be what type of pattern? Geometric pattern. Why? Because only geometric patterns uses r. Not so. So when you're working out for a convergent series, it will only be considered for geometric patterns. Okay? So any confusion thus far? Alright. So say for argument's sake, you don't know what's happening here. The only thing you need to know is, for the sum, okay, before I go into that, if this is now the case that r to the n approaches, if n approaches infinity, from this formula r to the n minus 1 over r minus 1, if this is the case, and r is greater than negative 1 but less than 1. Okay? Remember what does r to the n now become? What does r to the n now become? 0. So if I replace r to the n with the 0 there, n is, and what is n in this case now? What is n? Infinity. So therefore now we can conclude a new formula. That is therefore S infinity, the sum to infinity terms, is equal to a into r to the n is what? 0 minus 1 over, is r 0? No, r minus 1. So in other words, on top here what do we have? 0 minus 1, negative 1. So on top you will have negative a over r minus 1. What will happen if I swap this around? Negative comes out, making this negative a positive. So S infinity is equal to a over 1 minus r. So S infinity is equal to a over 1 minus r, provided that r is greater than minus 1 but less than 1. Well, r is not equal to 0. So if you don't understand that long explanation that we use the calculator for, this is one thing you need to know only. They would never ask you to prove how you get this here. That's the one thing you need to know. That formula is also given on the formula sheet. Okay? So if they say calculate the sum to infinity, or they ask you to calculate the sum of an infinite series, or they tell you the series continues forever, or it's an endless series, anything that tends to the idea of infinity, we use this formula. And to test for it, and the only time it will work, where the series will converge, is when r is greater than minus 1 but less than 1. This is key for the use of this formula. If that is not met, if that condition is not met, then we can't use the formula. If r is equal to 2, we can't use the formula. If r is equal to 1.5 or negative 5 quarters, we cannot use this formula. Why? Because r is not between negative 1 and 1. Which means to say the series will then not converge. You guys understand? So I highlight that, that's very important. Okay. So let's look at an example dealing with this formula here. We're on worked example 1 on page 17. Worked example 1, page 17. The question says determine the sum to infinity. Now you see there? The sum to infinity. So what formula must we use? Which formula must we use? A over 1 minus 1. The sum to infinity formula. Of the sequence 16, 8, 4. So what is your r value here? Is r between negative 1 and 1? Yes. What's your a value? 16. For an infinite number of terms. So do the calculation quickly. Alright, so what do we get? A, which is 16 over 1 minus R. For those of you who don't know how we got half, we said term 2 over term 1. So it's 8 over 16, which is R. Which also confirms now that R is greater than minus 1, but this we don't have to state, okay? We don't have to show that. Okay. So that's going to give us, sorry, 32. What does that mean? That means to say you got 16 plus 8 plus 4. What's the next number in the sequence? 2. The next one? 1 plus. Okay, now if you just stop there, it's going to give us 31. That's all. Plus the next one? Oh, then a quarter, then an eighth, then 16th. Whoops. That's 0 common, eh? So let's see how much we got now. Whoops. 31,875. So if we add again, plus, that was an 8, the 16, plus 1 over 32, plus 1 over 64, 30, I made a mistake somewhere, 16, so what am I doing? Okay. It's 16 plus 8 plus 4 plus 2 plus 1. Did it was a half and so on. No? Right, there we go. My mistake there. It's 31,984 and so on. So remember I stopped at. What do you notice? It's approaching, it's coming close to 32. Let's carry on. Plus 1 over, what's the next number? 128, I think, no? Plus 1 over 256 plus 1 over 512 and so on and so on. The calculator is running out of memory already. Okay? This is the, you see, what do you notice? It's this coming closer and closer and closer to 32. It comes so close to 32 that at the end we just say it is 32. Can you see that, people? Because if we write to 2 decimal places, what is that number in other words anyway? 32. You guys understand? Would this number ever go over 32? No, it will never go. Okay? But it comes so close to 32 that we say it's 32. Make sense? Okay. And then as we say there, the series will converge. Okay. Let's look at worked example 2, and this is also on page 17. There we are told to consider the sequence, within this case the series, 16k plus 8k squared plus 4k cubed plus and so on. The dots indicate that it's going to carry on forever. It's going to attend, it's going to go to infinity. First question. For which value or values of k will the series converge? There's a common asked question. And the approach is simple. When will a series converge? R is greater than -1, but less than 1. Not so. So to answer this question, we start off with that statement. For which value or values will the series converge? The series will converge if R is greater than -1, but less than 1. It's a restriction that R can't be equal to. Okay, we start with that. So what is, how do we calculate R? T2 over T1. Or T1, T2, T3 over T2. Okay? So it's going to be T2 over T1. Remember term 1, term 2, term 3. Okay? So T2, which is 8k squared over 16k, must be greater than -1, but less than 1. You all agree with that? What can happen now? What can happen now, people? What? You can cancel. So what's going to cancel here? 8 goes into 8 once, 8k into 16 twice. K cancels with one of those k's. So what are we left with? K over 2 or a half k. It's the same thing. Has to be greater than -1 but less than 1. Now remember, this is what R is. Not so? So at this point we can say that k over 2 can never be equal to 0. So k can never be equal to 0. Not so? You all okay with that? So how do we get rid of the denominator of 2 here? Divide? You're making the same mistake as you made in the other side. What must we do? Multiply. Not divide, multiply. Because that's your denominator. Otherwise you could have divided by what? If you really want to divide, half is. Can you see that? So this would have been a half k. To get k on its own, I would have divided by half. Okay? So either divide by half or multiply by 2. Which is now going to give us -1 times 2 is -2, k 2. So in other words, k has to be greater than -1. Sorry, k has to be greater than -2 but less than 2. You guys understand? Something like this is worth 2 marks. It comes in often. Okay? Again, for which values or value of k will the series converge? The series will converge if k, no, not k, series will converge if R is greater than -1 but less than 1. We work out R by saying T2 over T1 and we simplify. Okay. 2 marks is here. No, one is for that substitution and one is there. They really haven't seen them penalized for not stating that part. Okay, but state it because that's your restriction. Okay, you'll see many memos also don't have it. I don't know why. But I think it should be. Okay. Because if k is 0, then the series won't converge. It will be something else. It will just be zeros. It will be an arithmetic. It's actually an arithmetic. Because the 0 divided by 0 is what? 0. Check. What 0 divided by 0? Anything divided by 0 is undefined. Not so? So it's actually not a geometric series. Won't have an odd value. Okay? That's why I always put this in here. I think 1 or 2 textbooks also have that, like it. But you'll see in the memos they don't have it. Okay? But okay, let's carry on. In number 2, it says calculate the sum of the series to infinity if k is equal to -1.5. Would the series converge at -1.5? K value at 1.5. Yes or no? Yes. Why? Because there's a good start. Because yes, k is greater than -2. K has to be greater than -2 but less than 2. Okay? For those of you who's probably saying no, you are thinking of r being greater than negative 1 but less than 1. But what are they talking about here? K. So will the series converge? Yes. Because it does conform with what we have just calculated. So if k is equal to negative 1.5, what can I do with that? I can now work out my first 3 terms of the sequence. Not so? So what I'm going to do is, I'm going to substitute number 2 now. Substitute negative 1.5 wherever I see k. Okay? So what would that now be? 16 into negative 1.5 plus 8 into negative 1.5 squared plus 4 into negative 1.5 cubed plus. So this would be what? 16, 8 is negative 24. Let's check if I'm correct. Negative 24. Negative 1.5 squared is 9 over 4 is 8 is 2 is 19, 18 is positive. The next one of course has to be negative. It's 27 over 8 is 2 is 27 over 2. Is that correct? Yes? But have I answered the question? Have I answered the question? No, the question is to calculate the sum of the series to infinity. So how do I do that? How do I do that? S infinity is equals A over 1 minus R. What is my A value? Negative 24 over 1 minus. How do I calculate R? Remember R is going to be T2 over T1, which is negative 2 over 3 over 4. So that's going to be into negative 3 over 4. So what does that give us? I get negative 96 over 7. Is that correct? Okay. And that's our answer. Any confusion? No? Right. For homework. I want you guys to do exercise 7 on page 17. Then you read through sigma notation, the stop part here, before the example, and this things to remember on the side here for Monday's lesson on page 18. Okay. People, don't forget about this afternoon's lesson. It's last year's paper 2 that we will be addressing this afternoon. Enjoy the rest of your day, and for those of you I don't see later, enjoy your weekend. Don't forget to tell the other class that they are welcome as well. No? Yes? Yes, in this class.